We're founded in 2000, but actually we started into the video starting from 2002. We started to broadcast video. The broadcast video is something very different from today's video we're talking about, because today's video we're talking about is a fixed camera at a fixed position. But broadcast video is very, very different. Broadcast video is to shoot every camera according to the dimension, according to the scene. So the background is moving. So the background is moving is much harder than the background is not moving. So we solve the problem, the background moving video, and then we come back and solve the fixed camera problem. Why is that? It's because the video camera or the video technology started from very, very early in broadcast instead of surveillance. Surveillance 460 analog CCTV was introduced a long time ago, but never changed until 2010, right? So 2010, we started seeing standard definition video camera, and then we started seeing high definition. We started to see 2K, 4K, 8K. But back in the 2002, we already used standard definition broadcast in TV. And then 2004, we started using HD. Then we started to look into Super HD, and we looked into 8K in 2010. But the surveillance camera or the fixed camera on the device is far behind. So the camera technology is been introduced a long time ago, but at the same time, the CPU performance versus the video quality is not there. Why is that? Because when we did the first generation artificial intelligence on the video camera instead of broadcast, if back on broadcast, we started from 2004. But on the surveillance camera, we started from 2010. So when we start with that, then we found out the CPU or the GPU is just not there, because the computing power is purely for digital content, but instead of on the text instead of the video. Even on the video, it's still very, very low quality image mode. So once we go to today's 1080p, for example, right? Or 2K, 4K, a lot of people are using 8K lenses. But once we go in there, the next question is going to be, is the CPU ready? Is the GPU ready? Is the computing power ready for this kind of technology? And then if you want to do artificial intelligence, the basic concept is you want to get every pixel of the video or image to be computed and to analyze and to understand what that pixel means. So if we're talking about the median pixels in one frame, and then we're talking about 30 frames per second, then you need humongous computing power, and then to do something such that the video makes sense. So what I'm going to talk about today will be what we've been doing with Intel in the past years, and then especially in the last couple months, and how do we empower the CPU to do something different, and then not only the conventional CPU, but purely on the video section or image section. And then what we found out, and then what we can offer today, and then especially for your business, right? So this is what I'm going to talk about today. All right. So the artificial intelligence trend, everybody talk about artificial intelligence. So first thing you thought about it is a robot, right? And then you talk about a robot, you talk about machine, and then, but the most important thing is the brain. The artificial intelligence is nothing but the brain. Then the brain is coming from computing power, coming from CPU, GPU, NPU, BPU, right? But when you come into the brain, if you take yourself, that's one example. What people can see, what people can see. You have to see it, you have to smell it, you have to touch it, then you have to make a decision to the next move. That's artificial intelligence in general, right? So why IoT related to artificial intelligence? Because IoT is nothing but a sensing technology. He sense, and then he delivers information, he delivers insight, and then back to the brain. Then the brain has to make a decision, analyze it, and then they make it. So that's artificial intelligence, right? So if we talk about the history of the artificial intelligence, everybody remember IBM Blue. That's back on 10 years, 20 years, when I was very young. We started looking into how IBM Blue can do this, can do that, But if you look into a computer, that's a huge computer in a huge room. But today, we're talking about a smart display. And then with the little GPU inside, so we do something about it. And then what do you want to do about it, right? So that's your business, but that's how Gorilla and Intel can facilitate you to do something very, very different. So that, I kind of reduce that word a little bit, minimize that word a little bit, from artificial intelligence into smart. So smart means this is a dummy devices, now I turn into smart device. This is a dummy IPC, a dummy gateway. Can I turn into a smart gateway? If this is a server, can I turn into a smart server? Right? That, kind of an understanding, right? Intelligence is kind of far away. But let's put it back a little bit. How do you want to be smart? Let's say, okay, I want a smart access door. So when I come in, I don't use my RFID. And then that door recognizes me, and that door can open. That's a smart door, I'm thinking about it. So if the smart signage, what signage can do? The signage is display some information when they see Dr. Koh come in, they want to give me some information I wanted, not everybody else. So when I look into the device, then they say, oh, all right. You say, welcome, Dr. Koh. You have a session at 7 floors, called Marriott. Go up there. Okay, that's a smart. If you can do something like that, I'll say, okay, that's smart devices, that's smart display, it's for briefing. How about the others? What you can do about the smart display? And then in retail, right? If we walk in the store, say this is a female dress store, and then if you are certified, professional, very nice looking girl, and you walk into the signage. The signage original display some guys sportswear. When they see you, they change the advertisement to something different. It's a certified around young girl a sportswear. How about that? That's something probably your client wanted, and that customer will be very pleased, right? And then if you want to do something a little bit more, and then you will suggest you to say, okay, try this, girl, and try that. So you upsell. So that is what we call a device. It's a dummy or it's a smart, right? So that's what we're going to talk about today. All right, so this is we grabbed from one of the sources, the Signage Insight. It's not from me, but it gives you a brief idea what the artificial intelligence is a trend, but we bring it back a little bit, and then talk a little bit about technology, decentralization, democratization. What that means? It means give you a new feature, means the edge can play something different. It's not only the cloud, it's not only the data center, it's not only the server farm, because the server farm is a bunch of the CPU put together, right? And then to do a lot of the computing. But why can't I do just one CPU to do something a little bit smarter? That's the concept. But what if I can bring everything from edge to the gallery, to the server, to the cloud, and then mix together as a software-defined computing network? Then I can manage almost everything. So that's what we call the artificial intelligence trend. And that's exactly what Gorilla has been doing in the last 10 years. And then we've been proving. Last year, we worked with Intel, we worked with Amazon, we worked with Telstra Cloud, we worked with Cat Cloud, we worked with Tencent Cloud, and then to prove this is doable. And then those guys said, wow, okay, because everyone is standing in a different position. When you talk to Amazon, we are on the 57th floor. I talked to their CEO said, hey, Dr. Koh, you see, we're on the cloud. How nice. I said, yeah, you're on the cloud, but you're not on the ground. You cannot touch the ground, right? They said, what do you mean by that? Because there's a lot of edge computing down the ground, you cannot touch it. So you need to collaborate with the edge computing. But once we go to the edge computing, that's a lot of stuff. Today, everybody is on the display. So the display can be i-core, i7, i3, i5, Atom, right? Celeron, anything. But the only thing you want to change it is that CPU, and then to make it smarter. And then the smarter things, depends on how big the computer power can be. That's the only thing, right? So if you sell 10,000 devices underground, say you own 10 shopping malls client, and then each client, when they see your smart devices, smart display, they say, well, I like it. I want 100 on each store, so we were going to order you 100,000 smart display. Let's put this. And then each one of it is individual, right? He's managing only that devices with that little lens. That little lens is fixed on the display and only view this angle. But together with 10,000 of the display, you literally see a lot of spaces which you never seen. And then you use all the lenses, grab it together, and then bring the inside back to the center, and then to see what's inside. So why is that connected to the cloud? Why is that connected to the server? It's because each individual devices has that lens, and then he's doing his job. But at the same time, don't forget, those data can be analyzed into a non-conventional data. Everybody is just familiar with the data, right? Bit and byte. But does anybody know what kind of a video analytics can bring to you a different data? Say facial recognition is one of the very simple one, because that's a face, and then bring you the face print. This is Dr. face. This is another guy's face. That's only one thing. But how about this can tell you the gender age? He's 35. He's male, and then he wears glasses. He wears this clothes, and then he's about 10 feet high or 3 feet high, and he gives you a lot of different information which you don't know it. How about that? If that information can be retrieved and then stored in a different way, which is a very, very unconventional database. So we're working on not only video analytics, but also provide a very unconventional, we call unstructured information database, and then we call it video IoT database, because IoT is a bit of byte coming with the time sequence and a location sequence. But once you go to the video, no, it's different. It's a three-dimensional domain. It's a temporal spatial database. So it has a location, it has the time, it has a time slot, it has a location, it has an angle, it's a position, yaw, everything. So once that information is in there, you are describing some data within the space, not in certain point. Then that data can be stored in a big database in no time, because you have a 10,000 display with the lens at the front, with the CPU is processing, giving you all the data, send it to the cloud. So the cloud is cranking and then talking about something different. Why? It's because, remember the first thing I said, the camera is not moving, but what is moving? People is moving, object is moving, vehicle is moving, car is moving. So what do you catch? Catch any movable stuff, and then convert that into a data. Once that is come out, then we collect tens of millions of data every second on the back end. Then the back end needs another computing power to crank in this unconventional data, and then to cross, and then to do a comparison, similarity, and then to bridge everything. And then give the final data to the client, then will tell you this young woman coming to this store, and then try this clothes, and then he goes to another store to buy coffee, and then he goes to another places to see this. This is what the client wanted, right? So don't minimize your business capability. You want a smart, and then you want not only smart device, you want smart devices to smart your business, to smart your customers' business, to smart the world. So that's what we'll be doing, and that's what we see in artificial intelligence training. So this diagram just simply tell you everybody is doing a little bit different thing on different devices, from car, from display, from PC, from whatever. But everything is computed. So once it's computed, the data will be collected. So why the cloud service provider are so keen to understand what computer vision can do? Why they are so keen to build a cloud with GPU, CPU, NPU, VPU, you name it? and then very, very big cloud waiting for the data come in. But you guys are very, very important because if you don't bring the data to the cloud, those guys are going to be dead because they have no data. They cannot deploy thousands, millions camera by themselves. They are cloud service provider, right? And then you guys are device provider. Then the device provider adds some lens in there. You're smart. You control the beginning of the data flow, and then you crank that data, send it to the back based on customer's need. That's the future, right? And then it's not the future as of today because we have implemented already. We have implemented in Australia, we have implemented in Indonesia, in Thailand, part of it a little bit in Taiwan, United States, and everywhere. And then we'll tell you it's not a story. It's happening, and it's being implemented. And then we've been working with different partners already. So cloud adoption accelerates AI innovation. I just mentioned that because why people Tesla is working on the ADAS, right? Automotive drive. And then to us, that's just the beginning. I'm in this field for years. And then when I say, since somebody asked me a couple years ago, he said, Dr. Koh, what do you say on artificial intelligence? I said, well, I don't really keen about those cranky names. Artificial intelligence, well, it's just people give the name. The only thing I'm looking into is what the unstructured data, what the unseeable data can be seen in the future. So anything I said is happening, and it's in the implementation today. And then if those data can be generated momentarily every second, that means someone has to take the advantage of the computing over the cloud, and then to compute, and then to provide the most innovative service in the future for every business. So now you heard about Industry 4.0, you heard about Bank 2.0, you heard about FinTech, you heard about the smart retail, even in China you heard about the shipping. So, right, everybody gives the new name. I don't really care about the new name, I only care about what we can bring in together with the CPU, and then bring those data to the computing, and then to generate a more valuable data, a more valuable intelligence, which never been given to the client. That's what we worry about it. And then can we do that? We need everybody's help. We need every devices, put on the lens, put on the vPro, put on the CPU, put on the ruler stuff, and then over there we can generate tons of data every day, every minute. And then those data can automatically generate, but not by conventional IT. Conventional IT, you write a program, then you generate data. No, this is not. You're not writing the program. You're using the video lens to generate data by the CPU and computer. That's it, right? So let's see something a little bit what McKinsey say. McKinsey, this one last year when it came out, the editor talked to me. He's based in San Francisco, and then when he came out, I said, "Wow, you said something similar to what I want to say," because he says when video meets IoT, he says IoT is not valuable just by itself, and then the most valuable things will come out to the business when the video meets IoT. Why is that? I heard someone tell me in a manufacturer, they have tons of IoT sensors, but they never trust the IoT sensor big data is real. Why? It's because that's machine data. It's not seeable data. You have to see it to believe it, you have to see it to evidence, you have to see it to see that's a forensic, right? So if you want to do that, you have to have people's eyes, but you don't have that many eyes, 24 hours. So what do? You use the lens, replace people's eyes, and then come out information which what do you need. That's the most important thing. And then this article is coming last year, end of last year. It's a very famous one. I think Intel got it, everybody gets it. And then this guy says something very interesting. He says, most influential data will be the video analytic data in the future. And then it has to be merged with the IoT in this field, such that we can go to transportation, we can do smart city, we can do smart building, we can do smart school, we can do smart retail, you name it. And then I'm the admin. I did this, I launched my product and my solution beginning of 2017. And in 1 year, we crossed 10 different verticals. A lot of innovative projects in Australia, in Asia, and in Taiwan even are done by Gorilla. Everybody heard about 2 years ago, Kaohsiung TAG. 6 people killed, 6 people kidnapped. The guy will be in jail, right? And then they shot itself. Why? Because they hijacked the gun, but they cannot get out. Then 2 weeks later, I was called by the Prime Minister. And they say, hey, Dr. Koh, you out. I said, what's that? He said, well, you read the newspaper. I know. Okay, what's going on? He said, well, can you create something called smart prison, smart jail, smart correctional? And then I remember certain guys over there told me, advisor of the president's house, and then other people say, that's impossible. And I sit down there for 20 minutes and say, okay, can I know what's going on here? And then after that, I say, let's go. Then, very, very good, they grant the project, and then we did a pilot, and then it will be announced by end of the year. There are 7 prisons in Taiwan, fully 24 hours monitoring, and then every second we generate millions of data to describe the heavy crime, what he's doing, who he's talking, everything. It's not video, it's data. And then those advisors visit the jail and look at the data and say, wow, how can it be? I say, wow, this is computer processing, and computer processing. So we convert the video into something readable. Right? You don't need to see million hours video. You see only the final data. That's it. All right? So that's one location. But once we put over here in transportation, can we monitor? Can we do something called ITS, Intelligent Transportation System, Intelligent Transportation Control? Can we know where this car is coming out? What happened at the front? Can we predict next 3 minutes? Can we do something else? Yes, of course. Everybody remember ATM heist. 47 ATM were heist by Ukrainian people, by mafia, right? A couple years ago, 1.5 years ago. You know how many days were caught? 7. 7 people were caught. The key guy of the mafia in Russia has been caught 2 months ago. Gorilla was in there, playing a very, very important role. We provide a lot of detailed information, similarity and everything, and then together. All right, so now we come back to a little bit about what we have done with Intel. Can I play that video? All right, so this one we've done at beginning of the year when we first worked with Intel 3S18, and then this is how we're using our deep learning optimization technology on top of the CPU only, i7 and the CM. And then what we found out is we outperform the entire performance 50%. Right? Now we're still growing, which means you don't need the GPU sometimes to do things. And then so far, we are optimized almost every CPU, right? So you can see over here, this frame rate per second is different. This optimization, you can see this, and that data is completely different. Why is that? Because original, the frame per second, say it's 30, for example. Now we're using the same CPU, and then we use a different technology. We use optimization, we use OpenVINO, and then it's 1.5%, 1.5 times. So the entire cost of ownership dropped a lot, right? So that means we not only use the image mode, we use the video mode, object tracking, object detection, facial recognition, all kinds of fancy stuff. And then we still can perform nicely. And then give you another example. A couple years ago, we tried GPU card from NVIDIA on i7, right? We tried facial recognition, and then we tried only 4 real-time channels. And when we check it out, still 4 channels. But today, even when we check out the GPU, we use the same CPU, we run it 6 channels, real time. So we optimize together the Intel CPU by 50%. That's a lot, right? So which means to tell you something you can do. So this one is just tell you how Gorilla's IVR, we call IVR, is market ready solution for Intel CPU. And then Intel CPU on the vision product for OpenVINO, that is the top one, and then Gorilla on top of it. So we have about 38 different analysts, analytics, from facial recognition to whatever you talk about. We cover 5 different kind of core, so for everybody uses. So facial recognition, generation, that's kind of one. Second, for vehicle. Third, for object tracking, detection. Fourth, for behavior, fighting, stuff like that. And then 5, for cross, we call IDM, which is a statistic used a lot in the retail scenario. So if we look into how we're working with the Intel, right? From Atom, Laren, Core, all the way to SIA, and for 1 channel means 1 video length. 2 channel means 2 video lengths. 1, 2, 4, 8, and then you can make your product very smart. That's what we do. Yeah. So if we talk about the devices of different cameras, of course you can do Solids, retail, Signage, whatever. But what can you do about non-retail stuff? I work in the marine for many years. So marine console normally is very, very specific. Certain people can hear, can see some instructions. Certain people cannot. If I'm a captain, when the screen come out, it has to be the captain's screen. When I'm a marine manager, it has to be that console, right? So the console is the dummy. The data is changing. So the lens of that dummy can visualize who that guy is, and then bring in the data, bring in the instruction of the workstation, of the Marine Corps, of everything into it. So it's right content delivered to right people at right time with right authentication. This is the whole concept, right? So if you broaden that, what you can do in different scenarios. So this is a commercial property. We use that a lot. I'm not sure what we have. Can I play on this one video? But I don't play it. It's very fun. Oh, this is Indonesia. This is right now running. This is the largest sports wear chain store. He has Nike, Skechers, Adidas, you name it. This is what come out. The data is like that. It's not video anymore. So he tell you how many people walk in, and then how many gender, age, and what time, and then what they see, where they stop, and then what they buy. Right? So all the data every 15 minutes pop up into the owner's cell phone. Now we integrate with their POS, we integrate with their ERP, and then so he doesn't need to go anywhere. So he say, oh, I can see this data. Very interesting. This owner changed the layout of one store in 1 month because his marketing team told him, oh, this store is a mid-age female becoming a lot, but turned out to be complete opposite. The data show up, no, it's not that. It's a young generation of male. So they changed Adidas, Skechers, everything on one store. And then the sales volume goes up. This is real, right? This one is office and work site. We use this one in Australia, very, very big building. So they analyze how many people walk in today, who is working in that space, who is working in that space, so they can manage the entire space layout, and then they can manage the losses. So video tells something very interesting here. And then the public area is something a little bit different. The public area, normally we're working on the, if you go to, so this is something you can see, this tracking. It tells you a lot of data over here, right? And the data will compute again and map in the database on the back end and give you some data. So this is seeable, but on the back end you don't see this. You see only the data. So this is only one CPU we can do. So we can do a lot of stuff, right? So I don't want to talk too much about technology. I just want to tell you what we can do about it. So CPU is a computer. So if your brain is, this is what we call adaptive physical computing. If this guy with sunglasses, with glasses, what if he take the glasses? You have experience in the immigration at the airport. If you don't have the glasses, once you wear the glasses, he doesn't let you go. This is not right. This is not right. This is image mode. Once you go to video mode, he has to recognize, he has to adapt because that's artificial intelligence. So the camera with the CPU, he will learn by itself. He will learn what is this, and then he will remember, and then he will recognize. So this is something we're using. So this is pretty much, I bring it here for everybody today. Just two announcements, very important. One is the market-ready solution is there, together with Intel OpenVINO and the visual product. Second, there's a lot of solutions, a lot of different offers on different display for different uses. We have many different customers in the world are working with us on specific design. And then I think what we can offer is, together with Intel, we can bring you the future, we can bring your customer future, we can bring the new world. Thank you very much.